All right, so this is going to be slightly more challenging than the last example, but the principle remains exactly the same because here in the last term, we have a fractional power on the inside of a radical. So how do we handle that? Really no different than the last problem, I promise. It's just you're going to have to use a calculator a little bit more. That's all. So first thing we need to do is simplify this so we have no radicals and all of our powers are on the top. So how do we go about doing that? We have 1 over x squared. We're just going to eliminate the radicals first. So we have 5 over x to the 7th to the 1/2 power minus 6.5 over x to the 7.1 to the 1/5 power. Okay, so as I said before, this is going to require a little bit of calculator work. So we're not really doing anything with this 1 over x squared just yet. But okay, so we have 5 over x to the 7th to the 1/2. So as mentioned in previous examples, this is going to require just multiplying your exponents here. So this is going to give you x to the 7/2. I prefer to keep things in fractions. If you want to turn into a decimal, be my guest. It'll work the same exact way. All right. So then we have 6.5 over, okay, now x to the 7.1 times 1/5. So we need 7.1 times 1/5. So what does the calculator give us? That's the same thing as 7.1 divided by 5. And my calculator gave me 1.42 in the exponent. All right? Hopefully you got something similar. Now that we have no more radicals to worry about and all of our exponents have been dealt with appropriately, what we're going to do is we're going to bring up all of our exponential stuff here into the numerator and negate the exponents, just like what we've done in the past like 6 examples. So bring up the first thing. So you have x to the minus 2 plus 5x to the minus 7/2 minus 6.5 x to the minus 1.42. Okay, now we have this in the general form that we need for the power rule. We have just a bunch of powers of x here. That's exactly what we need. So, deriving this gives us minus 2 x to the minus 3. Then we have 5 times minus 7/2, because we're going to bring this power down, including the negative in front, and multiply, and then subtract 1 from the exponent. So we have x to the minus 9/2. Okay, and then we're going to do the same thing over here. So we have minus 6.5 times minus 1.42, because we're taking the exponent, no matter what it is, bringing it down and multiplying. And then we subtract 1 from the exponent. So this gives us minus 2.42, because you're only subtracting 1 from the whole number part. Okay? The rest is just tedious calculation. So we have minus 2 x to the minus 3. So we have 5 times minus 7 over 2. So let's see what the calculator gives us. It gives us minus 17.5. And this is x to the negative 9/2. I've been told that my 9s look like g's. If it does look like a g, just know it's a 9. My g's look slightly different than this. I will insist this till the day I die. All right, and then now we need to multiply this third term fractions here. So we have 6.5 times 1.42, and the negatives cancel out, giving us 9.23 x to the minus 2.42. Okay, so that's it. We're just using decimals here. Same exact rules apply. You just have to hit the calculator a little bit harder. Final step, if you like, you could have finished this up right here. Final step, if you like, is bringing your exponents that have negative powers back down to the denominator where they belong. So you have negative 2 over x to the third minus 17.5 over x to the positive 9/2 plus 9.23 over x to the 2.42. And then this is your final answer. It doesn't really clean up anything more than that. So this is kind of as hard as they get. Hopefully at this point, these things are starting to make sense for you.